second period.
Oh, man.
And first period didn't go any better either, so. All right, 1.7, correlation coefficient. What do we call it? R. Very good. Tell me what you know about R. It's between what? -1 and +1. Earbuds out. -1 and +1. Okay? What does its sign tell you? Yeah, it tells you what kind of correlation you have. Positive correlation or negative correlation. Okay? The closer it is to 1, the better the fit. Y'all remember all this? Okay. So what's R squared called? Who remembers that? Very good. He remembered it from Algebra 2 last year.
I'm trying to remember anything.
Obviously he remembered something because he knew that.
He's sad.
I know, but still. What, he only remembers Mr. Collier's stuff?
Yeah.
Ooh. Okay. Yeah. All right. So R squared is the coefficient of determination, and it's actually like a percentage, right? Like almost like the percentage of points that lie on the line. Yeah. So if you had a .993, that would mean 99.3% of the points are on the line. That's a pretty good fit. Does everybody agree with that? Okay, so let's make sure you understand about R, or R squared. Let's say that I have two graphs. Here's one of them. What's that? He's an outlier. You don't let him screw things up because you do what to him? You exclude him. You chunk him from your data. He's a crazy wacko person. Okay? Yeah, that's me. I'm an outlier. Just throw me out. All right? The other one looks like this. Okay? One of them has an R that is .873. One of them has an R that is .969. Alright, first of all, they both have what kind of correlation? Positive correlation, that's why my R's are positive. If you drew the line of best fit, okay, it'd be somewhere up through the middle, alright? This one's R? Very good. His points are not as close to the line, alright? His R, his correlation coefficient, is not going to be as this one. This is a tighter fit. My points are closer to the line. Okay, so everybody remember that? Alright, so how do I make my calculator tell me what R and R squared are?
Well, then you got a linear regression. Put in your Scatterplot and do a linear regression.
How do I make my calculator tell me what R and R squared are?
You put in your data through this.
Yeah.
Yeah, and then you Scatterplot it. Turn on
Our stats.
and then you go to the calculator and you do linear regression.
No, let's not do that. Let's do one bar stat.
You gotta tell it, guys. It's not gonna automatically give you R and R squared unless you.
Oh, it's a linear regression.
Oh, turn on diagnostics.
There you go. You gotta turn your diagnostics on. If you don't turn your diagnostics on, then it will not give you R and R squared. And then I guess you'd have to be in stats, because in stats, do y'all figure it yourself? Learn how to?
If we did, I don't remember.
Oh, no? Okay. All right, so we just want the calculator to do it for us. There is a way to figure it yourself. I have no idea what it is, but there is a way. Okay, so let's go to our calculator.
Can you show us how to do it on the
Yes.
calculator?
That's what, get your calculator, and I'll show you how to turn your diagnostics on. Okay? So, here we go. So, y'all can do it one of two ways, okay? This is the only way I can do it because my calculator's old. But I'm going to go second in catalog. This A right here means I'm in the alphabet mode, okay, or the alpha mode. So I'm going to go down here to the D's, and then I'm going to go to diagnostics on. Oh. All right, there. So there it is. Is it on yet? No. You have to press enter, and then it says it turned it on. There's another place that you can get it, but I can't. You can go to mode and go to the second page and go to stats, diagnostics on or diagnostics off. Do you see that?
Where's the second page?
Just keep arrowing down or up.
It's not a second page,
Oh, it just keeps going?
it's like a bot.
Oh, okay. Sorry. So,
There's not.
does everybody see it?
It's on the first page.
It's on the first page.
Yeah, I see.
It's on the first page, not on the second page.
Why is it being off?
Yeah,
It's on the second page of those? Oh,
what
okay.
page is on the first.
Yeah, your new little fancy cool calculators. My calculators, nah, second page. Y'all just keep going down. Okay? Alright. So, is everybody okay? Can everybody turn their diagnostics on? Okay, good deal. Alright, so we're going to take the information that's on the board and we're going to make a scatter plot. Okay? The information over there on the left on the board, it tells you the year and the number of shares in billions that are exchanged, that are on the New York Stock Exchange. Okay? That's what that table tells me. Alright, so let's make us a scatter plot. We've already done scatter plots this year, so this shouldn't be an issue. What's the first thing I need to do? I'm doing it right here on my paper. And then I'm going to do it on the calculator, yes. But I want to do it on my paper first. I want to make sure if they ask you to draw one on the test that you can draw one. I got an X and a Y. So I got to label my X's. Y'all, if you don't label your X's, you're going to lose points. What are the X's? The years. What are the Y's? The number of shares. Do I have to put in billions? Yes, people. There's a huge difference between 154.7 and 154.7 billion. Okay? 154.7, and I'm coming to work tomorrow. 154.7, I'm not. 0.7 billion?
I found out a little. Apparently, a dude got arrested because he had a
Okay, so this is the number of shares in billions. Years, where do we go from and to and by? Where do we go from? 1995 to 2001. Where do you want to go by? 1. If I start at 1995, what do I need to do? Yeah, you got to do a little break.
Is it cool if we just put like 95, 96?
Yeah. Usually on the first one I put 1995 so everybody knows, but if you do that little apostrophe or whatever that thing's called. So there's 96, here's 97, 98, here's 99, there's 2000, and there's 2001. Okay? Now, what about my number of shares? From, what do you want to go from and to? 150. What do you want to go to? 350. Okay, what do you want to go by? I don't think 50s will be enough. 25 sounds good. Do I need another break? Yes, you do. Okay, so here's 150. Here's 175. There's 200. 225. 250. 275. 300. 325. 350. And now I'm going to graph everything. 1995 was 154.7. 1996 was 176. 1997 was 207.1. 1998 was 239. There's 25, 39. 1999 was 280. Here's 275, so 280. 2000 will be 313.9. 2001 will be 341. Yes. Sure. Okay. Does it look pretty linear?
Yeah.
Looks pretty linear. Okay. So now we're going to do it on our calculator. Okay. So, huh? Mine looks pretty linear.
Mine looks like it's curved to it.
Okay. So on our calculator, I'm going to go to Stat and what? Edit. Okay? You're going to put your X's in list 1 and your Y's in list 2. What if you chose to only put 95, 96, 97, 98? Is that okay? What would you need to do on your paper? Very, very careful. No? You better tell me because I'm grading that paper, okay? And if I use 1995, 1996, and you use 95 and 96, are we going to have the same slope? Yeah, we will. People, that's not going to affect how that line goes up, okay? What are we going to have different? Our y-intercept will be different, okay? And so I'll think yours is wrong if you don't tell me, hey, I used 95 for 1995, or I used 5 for 1995. Whatever you did, you have to tell me, okay? Because that's going to make your y-intercept different. Is everybody okay with that? Okay. So now if we wanted to do a stat plot on our calculator, we would go second and y equals. We would choose number 1 and turn it on. You can choose your type of graph, a scatter plot, a line graph, a bar graph, box and whiskers. We're doing a scatter plot. My X's are in list 1 and my Y's are in list 2. I like the big square as a mark. This is normally where kids go Zoom 6 and they graph it, and then what do they say? I'm saying there's something wrong with my calculator. My graph's not there. And I'm like, oh, did you look at your windows? Okay? Because you're looking at a different place in the graph. What did our X's go from and to? 1995, 2. And I like mine to be 1 less. 1994. I'd rather use my brain. To 2002.
Cool with me. That bothers me, Chris.
Okay, and I'm going to go by 1.
Zoom 9 if y'all want to have to do that.
Have I ever had to use Zoom Fit or something like that? Yes, if I get a crazy equation that I have no earthly idea what it looks like or where it's going to be, I'll Zoom Fit it and then play with it to figure out what part I'm doing. Okay?
Zoom 9.
Okay, so my Y min was 150, and we went to 350, and we went by 25. Okay, so this is exactly what our graph on our paper looks like. Now if I want to do a regression on it, what do I do? Stat, calc. Number 4 is linear regression. Now yours looks different than mine, right? Yours says, I don't know, blah, 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 X list, Y list, frequency, store reg equation. Go down to store reg equation. Store, R-E-G-E-Q. Go down there. Go alpha and F4. Alpha and F4. Okay?
Oh, you can store it.
You can store it. This is the only way to make it show up on your graph. Okay? So press Y1. Okay? And then go down to calculate, and it'll pop yours out. I have to do mine like this. Second and L1, comma, second and L2, comma, bars, Y bars. Yes, it's a function. I want to start right there. Okay, so this is what you should have gotten. Does anybody remember how many decimal points I like them rounded off to? 3. Very good. So y is equal to 32.436x minus 64,561.657.
Two decimal things?
3 decimal places. R squared is 0.995 and R is 0.997. Just listen to R squared is simply R squared. Okay? And what it does is it shows you if you're comparing things and there's such a small difference right here you can't tell, this is going to be a bigger difference. Okay? It's going to be a bigger difference. So that's what they use it for. Alright, so is everybody okay on this? Alright, if you wanted to look at your graph, you can see that it's about 99.5% accurate. So if I graphed it, I can see that he hit every point, but he only went through how many? 1. That's the only point he went through. The rest of them, he touched them, but that's why it's not a perfect fit. It did hit them all, though. So pretty good, pretty good. Alright, so one more little note. Do you know the difference between interpolation and extrapolation? Okay? Do you know the difference between interpolation and extrapolation? If I said use your regression line to predict the number of stocks on the New York Stock Exchange in 2008, what would I be doing? Interpolating or extrapolating? Why are you extrapolating there? Very good. And extrapolation is outside your data. Is it good to extrapolate?
No.
Okay. It's used a lot, though, right? Is Nike going to extrapolate and figure out how many shoes and shirts and shorts they're going to make next year from this year's data? They are. But you just want to stay close to your data. That's 7 years. We're good. Hey, okay. So outside your data, so we use this extrapolating, but we always try to stick really close. I mean, this is what your companies are going to use. So is Nike going to use data from a long time ago to extrapolate? No, they're not. I mean, what's this say about the New York Stock Exchange? Well, if everything keeps going like it is going, this may be how many we have. But if we have a war, will that affect this? Tremendously, okay? So it's just taking all those things that you don't know what are going to happen out of the equation. This one is within my data. It's a little safer. Okay? So tomorrow we're going to work problems from inverse functions, showing algebraically that they're inverse functions, and we're going to work problems on linear regression. Okay? Should be an easy day for you.